Leetcode 118 Pascal triangle. We'll learn how to construct the first 5 rows of Pascal triangle like this. I'm going to copy it and put it right here. In Pascal triangle, each number is the sum of the 2 numbers directly above it. In other words, each number is the sum of the above left number and the number directly above it. Let's say if we want to calculate the value at row I, column J, it is the sum of the left above number and the directly above number. This is above left. Let's implement with Python to construct the first 5 rows step by step. Create an empty array to store each row. For each row from 0 to 4. Create an array filled with 1s. Row 0 has 1, 1. Row 1 has 2 1s. Row 2 has 3 1s, and so on. For every number from column 1 to the second to last column, update it with sum of above left number and the directly above number. Once done with a row, append it to the triangle array before continue processing to the next row. Finally, once all the rows complete, return the triangle array, which contains us 5 rows of the Pascal triangle. So instead of 5, we can generalize by change to num row. Alright, time to smart the submit button. Boom! Accepted. This problem is a classic example of building arrays dynamically using nested loops. It also teaches us how to carefully index into previous data structures to build new ones. Time complexity is big O of n squared. N is number of rows because we build each row and update elements inside it. Space complexity also is O of n squared as well, since the triangle stores all rows. If you found this helpful, be sure to subscribe to the channel for more Leetcode problem walkthroughs like this. I'm Alan, and this was Leetcode Simplified. Thanks for watching. I'll see you in the next one. Hello everyone, welcome back to Leetcode Simplified. I'm Alan. Today we're tackling Leetcode 119 Pascal Triangle 2. We learn how to construct the 4 rows of the Pascal triangle in place. In Pascal triangle, each number is the sum of the 2 numbers directly above it. All rows begin with 1. What's go here? It's the sum of 2 numbers directly above it. 1 plus nothing equal 1. What's go here? Sum of 2 number above it. 1 plus 1 equal 2. Next, 1 plus nothing is 1. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus nothing is 1. Next, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus nothing is 1. We want our function to return row 4 only. First, we're going to initialize row 4 with all 5 ones. After rounds of going through each column, we modify row 4 in place and return it. For each row, update the row from the second to last column going right to left so we don't override values we still need for calculation. Each element of the row becomes the sum of the element above left and the element directly above, preserving correct values as we go. We can also write this more compactly. Instead of just the 4th row, we can generalize this by replacing 4 with row index to generate any row of the Pascal triangle. Take a look at the diagram to see exactly how our code plays out. We skip I equals 0 and I equal 1 because no element yet changed in the row 4. So we can start from row 2. See nothing changed when I is 0 or 1. Jump straight to I equal 2. At this point, our row looks like 1, 1, 1. Now we update it from right to left, starting at the second to last position. Each element becomes the sum of itself and the one to its left. That gives us 1, 2, 1, which is exactly Pascal triangle row 2. Next, move to I equal 3. Our row start is 1, 2, 1, 1. Again, we go right to left. First update 2 plus 1 equal 3 and 1 plus 2 equal 3. Finally, I equal 4. Row start at 1, 3, 3, 1, 1. Now, right to left. 3 plus 1 equal 4. 3 plus 3 equals 6. 1 plus 3 equals 4. And boom! 1, 4, 6, 4, 1. Row 4 complete. So initially this row has all 1. After the 4 loops, this row returns this. And that's it. It's time to smart the submit button. And boom! Accepted. This problem is a great example of in-place array updates to save space. Time complexity big O of k square because we update multiple positions for each row. We build k's number of rows. Space complexity big O of k because we only store a single row instead of the entire triangle. If you found this helpful, be sure to subscribe to the channel for more Leetcode problem walkthroughs like this. I'm Alan and this was Leetcode Simplified. Thanks for watching. Hello everyone, welcome back to Leetcode Simplified. I'm Alan and today we're solving Leetcode 121. Best time to buy and sell stock. Given a list of daily price of a given stock, find the maximum profits you can make by buying on one day and selling on a later day. For example, given a list of prices, if you buy at price 1 and sell at price 6, your profit is 6 minus 1 or 5. The maximum possible profits you can achieve. Look easy for this list, right? But what if the given list have thousands of prices? Here's the cleanest, most optimal solution to find the max profit in just one pass through the list. Read each number. If it's smaller than the current minimum, update the current minimum to it. Otherwise, subtract it to the current minimum. If the result exceeds the current maximum profit, update the maximum profit to this difference. To implement this, we keep two variables, current minimum price and current maximum profit. Both get updated as we go through each price. Let's code it up. First, set min price to infinity so any price we see will be less than it initially. Set max profit at 0, no profit yet. Then for each price in the list, if it's less than our current min price, we update min price because this price is better to buy. Otherwise, if the price is bigger than the current min price, then subtract it to the current min price, and if the difference is bigger, update the current max profit accordingly. By the end of this loop, max profit holds the maximum possible profit. Look at the list on the left. Initially, min price is set to infinity and max profit is set to 0. Min price and max profit will be updated accordingly when we go through each price in the list. Price 7 is smaller than infinity, then we update min price to 7. At price 1, it's much better than 7 current min price, so update min price to 1. The next day, price is 5, which is larger than the current min price 1. So the profit is 4. Update the current max profit variable to 4. The next day, the price we encounter is 3, which is larger than the current min price 1. So we subtract it to the current min price to find the profit. 2, which is not greater than the current max profit 4. So keep 4. The next price is 6 greater than the current min price 1. Subtract the current min price to find the profit. 5 is greater than the current max profit 4. So update max profit to 5. The next day price is 4 greater than the current min price 1. So subtract 1 from it to find the profit. 3 is not greater than the current max profit 5. So we just keep max profit as 5. No more price to read. Max profit holds the maximum profits you can achieve with this list. Alright, time to submit our code. Boom! Accepted. And that's it. A simple, elegant solution to find the max profit. We only pass through the list once, so it's big orb and time complexity. We use only 2 variables, so it's orb 1 space complexity. If you found this helpful, be sure to subscribe to the channel for more Leetcode problem walkthroughs like this. I'm Alan, and this was Leetcode Simplified. Thanks for watching. Hello everyone, welcome back to Leetcode Simplified. I'm Alan, and today we're tackling Leetcode 136 single number. Given a non-empty array of integers, every element appears twice except for 1. Find that single number. For example, 1 is the single number in this array, and 4 is the single number in this array. Because every other number appears twice, the problem asks us to implement a solution with the big orb and time complexity and big orb 1 space complexities. We can't use solutions like counting hash map or using extra memory. Instead, we're going to use XOR operator to solve this problem in just one pass linear time and using only one variable to store the result. Let's quickly look at XOR bit operation. 1 XOR 1 equals 0. 1 XOR 0 or 0 XOR 1 equals 1. 0 XOR 0 equals 0. From this, we observe 3 very important properties of XOR that will help in this problem. Any number XOR with itself equals 0. A XOR A equals 0. Any number XOR with 0 stays the same. A XOR B equal B XOR A. XOR is commutative. Order doesn't matter. Using these 3 properties together, when we XOR all the numbers in the array, every duplicate cancels out to 0 and a single number remains. Understanding the intuitive behind this is a bit tricky, but the actual coding is simple. Let's code it up in Python. First, we need a variable to store the result. Set it to 0 because after XOR with the first number is added into the result unchanged. Which is the number in the array, we XOR it with the current result and update result to hold this new value. After the loop finishes, all the duplicates have cancelled out to 0 and result holds the only number that appeared once. Return result. Now let's take a look in detail at example 2. Here's our array numbers in binary. The first one in a number flips the corresponding bit in the result. When a second one appears in another number, the bit flips back to 0 to cancel them out. At the end, the result is 1, 0, 0. Alright, time to smart the submit button. Boom, accepted. And that's it. Using XOR, we solve it in linear time with constant space. If you found this helpful, be sure to subscribe to the channel for more Leetcode problem walkthroughs like this. I'm Alan, and this was Leetcode Simplified. Thanks for watching. See you in the next one. Hi everybody, welcome back to Leetcode Simplified. I'm Alan, and in today's episode, we're tackling Leetcode 141. Linked list cycle. Given the head of a linked list, determine if the linked list has a cycle. That means there is some node in the list that can be reached again by continuously following the next pointer. For example, the last node -4's next pointer points back to node 2 in the list. To detect a cycle in a linked list, we use Floyd's cycle detection algorithm, also called tortoise and hare method, the slow and fast pointer technique. A slow pointer moves one step at a time, and a fast pointer moves 2 steps at a time. If there is a cycle, the fast pointer will catch up to the slow pointer at some point. If there is no cycle, the fast pointer will reach the end of the list first, at when we will return false. Think of it like two runners on a circular track. The slow runner jogs steadily, while the fast runner runs laps and eventually catch up to the slow runner from behind. The logic is easy to grasp, and turning it into code is just as straightforward. First, create slow and fast pointers, both pointing to the same node as head pointer. While fast and the next node exit, keep doing these steps. Move slow 1 step forward. Move fast 2 steps forward. Then check if fast points to the same node as slow. Return true. If fast is none, that means it reached ends of the linked list. There's no cycle. Return false. Now visualize the logic step by step with the example on the left. Create slow and fast pointer that point to the same node as head, as long as fast and the next node exits. Advance slow 1 step and advance fast 2 steps. Then check if they both point to the same node. If not, repeat the process until they meet. Then we return true. There is a cycle in the linked list. If there's no cycle, fast pointer eventually will point to none without ever meet slow pointer. There's no cycle, so return false. Alright, time to smash the submit button. Moment of truth. Boom. Accepted. With Floyd cycle detection, we get super clean, efficient solution, all end of time, or 1 of space. Simple logic, powerful result. If you found this helpful, be sure to subscribe to the channel for more Leetcode problem walkthroughs like this. I'm Alan, and this was Leetcode Simplified. Thanks for watching. See you in the next one. Hello everybody, welcome back to Leetcode Simplified. I'm Alan, and in today's episode we're tackling Leetcode 160, intersection up to linked list. Given the heads up to singly linked list, find the intersection node. If no intersection, return none. For example, C1 is the intersection node as we can see in the diagram. If list A's length m is different from list B's length n, then pointer A and pointer B will not reach the intersection node at the same time, because they move different number of steps in their first pass. How to make them to reach the intersection node at the same time? Let's say x is the length from head A to intersection node C1, and y is the length from head B to the intersection node C1. If two lists intersect, the shared tail has length m minus x in list A and n minus y in list B. Well, it's the same tail, isn't it? M minus x equal n minus y. Rearranging, m plus y equal n plus x. This tells us that if pointer A traverses m nodes on list A, then y nodes on list B, it will reach the intersection node at the same time as pointer B, which traverse n nodes on list B, then x nodes on list A. The special case is when two lists not intersect, then x equal m, y equal n. Pointer A travel m and travel n before reaching none. B travel n and travel m nodes before reaching none at the same time. And when A and B both point to none, return A or B means return none. Alright, let's transpile the idea into Python. First, take care of some obvious cases. If either linked list is empty, return none. Create pointers A and B to point to the same nodes, head A and head B, respectively. As long as A and B are different, move A one step forward, if not NList. Else, if NList, A goes to head B, the head of the other list. Similarly, advance B one step forward, if not the end of the list. Else, if it's the end of the list, B goes to head A, the head of the other list. When A and B both point to the intersection node or none, if not intersected, return A or B, doesn't matter. The pointers A and B may reach the intersection node at different numbers of steps in their first pass, but because it traverses both lists in total, they reach the intersection node at the same time, at which we can return either pointer A or B that both point to the intersection node, or none if not intersected. Alright, time to smash the submit button. Moment of truth. Boom, accepted. This method runs in O m plus n time and use O1 space. Simple logic, powerful result. If you found this helpful, be sure to subscribe for more Leetcode walkthroughs like this. I'm Alan and this was Leetcode Simplified. Thanks for watching. See you. Hello everybody, welcome back to Leetcode Simplified. I'm Alan and in today's episode we tackling Leetcode 168, Excel sheet column title. Convert column number to Excel's column title. For example, column number is 1, column title is A, 2, B, C, 3, 26, Z, and so on. So we can see that Excel numbering system is a one-index base 26 system. Before we dive into this Excel style system, let's first review our zero-index base 10 system that we are very familiar with. Look at the number 731. From this representation, we learn something very important. 731 modulo 10 gives us the remainder 1, the rightmost digit. Then integer division by 10 to remove that rightmost digit, leaving the remaining number 73. Repeat this process with the remaining number. 73 mod 10 equals 3 to get the next digit. Then 73 integer divide 10 to remove that digit, leaving the remaining number 7 to be processed next. The remaining number 7 modulo 10 gives us the remainder 7, the next digit. And 7 integer divide by 10 equals 0. The remaining number is 0, done. So what we just did is modular gives the rightmost digit and integer division removes it. Repeat to extract all the digits from right to left. Now the Excel's one-index base 26 system is similar but with a twist. Digits go from 1 to 26, but our modular 26 produce 0 to 25. So how to fix this difference? Subtract 1 before modulo. Let's shift the number into the 0 to 25 range, so the modulo operation correctly mapped to the letters. So subtract 1 from the column number 731, then modular 26 to get the remainder 2, which correctly mapped to letter C in the alphabet. 730 integer divide 26 to remove the rightmost digit 2, leaving the remainder number 28. Repeat the process with the remaining number 28. Repeat the same process with the remaining number 1. The remaining number now is 0. Done. No more number to process. So we can represent the 731 in the 26 base system as, since we subtract 1 before, now we need to add 1. number 731 corresponding column title is ABC. Here's the Python implementation following the steps we just discussed to convert a number to its Excel column title. Start with an empty string column title where we will build the Excel title. We loop until column number becomes 0. Subtract 1 from column numbers because Excel system starts at 1 instead of 0 and our modular operation can produce 0. Column number modulo 26 gives us the remainder. 0 means A, 1 means B, 25 means Z. Use ordinal function or and char functions to convert the remainder into the corresponding letter in the alphabet, building our Excel column title one character at a time. Prepend this character to the column title string because we build characters from right to left. After adding the character to the column title, integer divide column number by 26 to move to the next left character. Repeat this process until the column number becomes 0. Start the final column title. Alright, time to smart the submit button. Moment of truth. Boom, accepted. This method runs in big O of log base 26 of n time complexity because each step we divide the number by 26 and use big O of 1 extra space aside from the output strings. If you found this helpful, be sure to subscribe for more Leetcode walkthroughs like this one. I'm Alan and this was Leetcode Simplified. Thanks for watching. See you in the next one. Hello everybody, welcome back to Leetcode Simplified. I'm Alan and in today's episode we tackling Leetcode 171 Excel sheet column number. Convert Excel column title to its corresponding column number. For example, given column title A, column number is 1, B is 2, Z 26, and so on and so forth. So basically, Excel columns are a base 26 number system, but instead of digits 0 to 25, we use letters A to Z that maps to 1 through 26. What about 27? 27 equal 26 plus 1. 1 means A, but this 26 also means A. The first A is 1. If we increase 1 at a time, it takes 26 time from this A to go to this A, this position. What about another A is in A. For the leftmost A, multiply it with another 26. It means we multiply 26 two times or 26 times 26. So in short, for A, the rightmost A doesn't get multiplied by 26 at all. It just stays its value to 1. The middle A gets multiplied by 26 once. The leftmost A gets multiplied by 26 two times. Concatenate all A's letters, meaning adding all their numeric values together, and you get the total column number. What about B? What about ABC? You can see the pattern clearly. Each letter's value is multiplied by 26 to the power of its position from the right, starting at 0. When we read each letter from left to right, multiply the current total by 26 each time, then add the letter's numeric value. It automatically handles these powers of 26 for us. Here's the Python implementation following the steps we just discussed to convert Excel column title to its corresponding column number. Initialize column numbers as 0. For each letter in the title from left to right, multiply the current total by 26. Then add the numeric values of the current letter. Let's convert the letter into its numeric value. Its ASCII code, subtract the ASCII code of letter A, and add 1 because A maps to 1. Update the column number with these new values. Return the final column numbers once all the letters are processed. Alright, let's hit the submit button. Moment of truth. Boom, accepted. This simple formula works for any length of Excel column title, and the key idea is always multiply by 26, then add the letter value. Time complexity is big O of n, where n is length of the column title because we loop through each letter once. The space complexity is big O of one constant space. We use only single variable column numbers. If you found this video helpful, make sure to subscribe to Leetcode Simplified for more step-by-step workflows. I'm Alan and this was Leetcode Simplified. Thanks for watching. I'll see you in the next one. Hello everybody, welcome back to Leetcode Simplified. I'm Alan and in today's episode we're tackling Leetcode 169, the majority element. Find the majority element that appears more than half of the time in a given array. Guarantee it always exists. For example, number 3 appears 2 times out of 3 elements, more than half. In the next array, number 2 appears 4 times, more than all other numbers combined. So 2 is the majority element. The straightforward way to find the majority element is to count the frequency of each number using a hash map. Whichever number appears the most is the majority element. This works, but it requires extra space, the hash map. We will take a look at a much more elegant solution known as the Boyer-Moore voting algorithm. Here's the key idea. If the majority element appears more than all others combined, then even after subtracting one occurrence for each other element, the majority element's count is still at least 1 left. Think of the majority element as the election winner. The winner already has more votes than any other candidate combined. Even after subtracting 1 vote from the winner for each vote other candidates got, the winner still have at least 1 vote left over. Let's translate this idea into Python. While scanning through the array, keep 2 variables, candidate for the potential majority element and count for how many votes it currently has. Go through each number. The rules are simple. If count is 0, we don't have a candidate yet. So set the current number as the candidate and set count to 1. The first number we encounter is 2. So we set 2 as the candidate and give it a count 1. Moving on to the next number. If it still equals the current candidate, just increase the count of the current candidate. The current number now is 2, which is still the same as the candidate. So we just increase the candidate's count to 2. Continue with the next number. If it's different from the current candidate, decrease the count of the candidate. We are now at the current number 7, which is different from the candidate number 2. Then decrease the count of the candidate to 1. Next, current number 0, which is different than the current candidate 2. So decrease the count to 0. Next, this time the current candidate got 0 count. Replace candidate with 9. 9 got 1 count. Next number is 2, which is different than the current candidate 9. Then subtract 1 from count. Next, current candidate 9 has 0 count. So replace candidate with the new number 2 and its count is 1. No more number. Loop ends. Return the candidate which points to the majority number because its count is more than all other numbers combined. Even in the worst case scenario, after cancelling out with all the different numbers one by one, number 2's count is still at least 1 left. Alright, time to smart the submit button. Moment of truth. Boom, accepted. This algorithm runs in O(n) of time since we scan the array once, and it uses O(1) of space because we only keep 2 variables. And that's it for today. With the Boyer-Moore voting algorithm, we can find the majority element efficiently without any extra memory. If you found this explanation helpful, don't forget to subscribe and check out the playlist for more Leetcode problems explained simply and clearly. I'm Alan and this was Leetcode Simplified. Thanks for watching. See you in the next one. Hello everybody, welcome back to Leetcode Simplified. I'm Alan and in today's episode, we're tackling Leetcode 190, reverse bits. Reverse bits of a given 32-bit size integer. Well, the first thing might come to mind is the naive approach. Convert the integer into a binary string, then revert the string and convert it back into an integer. This works perfectly, but it's inefficient and involves string operations. Instead, we can do this directly with bit operations. For example, given integer 13, its 4-bit binary is 1101. We demo with a 4-bit integer to keep it simple, but the exact same logic applies to 32 bits. Here's how we're going to reverse number 13 bits with direct bit manipulation in Python. First, create variable result to hold the reverse number. Initialize it to 0. Since this is a 4-bit, we're going to perform the following steps 4 times. Shift result left by 1 bit to make space. N and 1 reviews the last bit of N. Then we OR that bit with result to append it to the result. N and 1. Anything and with 0 becomes 0. Anything and with 1 stay the same. So 1 here and with 1 will stay the same. Then we OR it with the result to append that bit to the result and update the result. Anything or with 0 stay the same. So this won't change. Similarly, anything's here or with 0 stay the same. So we update result. Now we shift and write by 1 bit, making the next bit ready for the next iteration. Second iteration, shift result left by 1 bit to make space. N and 1 to get the last bit of N to here and append it to result by OR it with result. Shift and write by 1 bit, making the next bit ready for the next iteration. Iteration 3, shift result left by 1 bit to make space. N and 1 to get the last bit of N, then OR it with the result to append that bit to the result. Shift and write by 1 bit, making the next bit ready for the next and last iteration. Shift result left by 1 bit to make space. N and 1 to get the last bit of N, then OR it with result to append it to the result. So, reverse the bits of 13. We got 1011 or integer 11. For 32-bit integer, the exact same steps apply. Just repeat 32 times. At the end, result contains the reverse integer. Alright, time to smash the submit button. Moment of truth. Boom, accepted. This algorithm runs in big O of 31 time complexity with E constant, so we treat it as big O of 1. And it uses big O of 1 space complexity since we use only 2 variables, result and N. And that's it for today. We saw Leetcode 190, reverse bits using a clean and efficient bit manipulation approach. If you found this explanation helpful, don't forget to subscribe and check out the playlist for more Leetcode problems explained simply and clearly. I'm Alan and this was Leetcode Simplified. Thanks for watching.